Okay, how you doing? We're going to talk about a question that popped up. Someone asked me, what happens if you don't have pi here? What happens if, you have this interval that I'm talking about, that to find the period and the translation of this graph, doing some values to the inside, what happens and what occurs? So I'm going to talk about that in this video. And the question came, well, how am I going to use the 0 to 2 pi if I don't have a pi here and I can't actually subtract that? Well, I'm going to show you something that's actually going to work out quite nicely for us. I'm pretty sure it happens every single time, but you can't get away from using 0 to 2 pi. You just have to remember that pi is still a number. In the video I've done prior to this, I rounded it. I'm now going to show you leaving it in exact form and how it's a little bit better to leave it exact. And that's it. So here we go. Take a look at this function. There's some things that I can write out first right away if I want. And usually what I tend to do is I always tend to write out what my amplitude is going to be. So I usually come up here and I'll say, okay, my amplitude is going to be a 2. The absolute value of this. Okay, it's never, if it's negative, you don't write negative. It's the absolute value of that A. Because amplitude, remember, is a length, and length can't be negative. So the next thing I'm going to talk about is my vertical shift here. Do I have a vertical shift? Meaning, am I taking my axis and moving it up or down of the actual sine function? And in this case, I am, and I'm moving it down 1, so I'm just going to write a -1. The very next thing that I'm always going to talk about is the period. I will always go to this, and I am a huge fan of the idea of using a compound inequality. I know some people don't teach it that way. But using the compound inequality, you're going to find, or I'll show you here, that I'm going to be able to find so much information from that compound inequality that I don't need to worry about anything else. So here we go, compound inequality. So remember the original sine function went from 0 and it went to 2 pi. And I'm still going to use that 2 pi in the function. I'll show you what happens and how it works out nicely for us. So I then am going to alter the inputs. So I'm going to say that I have this 3x minus 2. And in this video, I'm going to leave it exact, which means I'm still going to leave pi in the video. I'm not going to round like I did in the previous video. So here we go. Let's add 2. And we're going to add 2 to both sides. Okay? Now, the beauty about this is that 2 pi plus 2, if I want to leave it exact, I can't multiply this by 3.14 ... I'm just going to leave it in that form. I'm going to treat pi as a variable. Although it's not, okay, pi is a number, I'm going to treat it as a variable. So I'm going to leave it, feel like it, and I'm going to treat it as like a y. So what I have is 0 plus 2 is 2, which is less than or equal to this 3x, which is now less than or equal to, again, treating this kind of like it's a variable, that I have 2 pi plus 2. So I've got this statement, we'll take 2 pi and add 2 to it. So then what I'm going to do is I'm just going to continue to solve for the x. So I divide by 3, and when I divide all of this by 3, remember in Algebra 1, when you do that y equals mx plus b, that you would divide each term individually? Well, I'm going to apply that same kind of concept here. So 2 pi divided by 3, and take this 2 and divide it by 3. And what I have here is that I've now got this new interval of 2/3 is less than or equal to x, which is less than or equal to 2 pi over 3 plus 2/3. Now, if you didn't use this compound inequality, your teacher may have taught it a little bit differently. You might have had a really hard time of realizing, okay, what is it that each step is going to be following after this? And the reason I like using this interval step is because wait until you see how easy it is for me to figure out what my period is. My period length, if the teacher asks you what is the period length, is simple. It is your end point minus your beginning point, and that's how you figure out your period length. So in this case, if I'm going to talk about the period length, I'm going to leave this up here in this idea of that it starts at 2/3 is less than or equal to x, which is less than or equal to 2 pi over 3 plus 2/3. And I'm going to talk about this idea of period length very quickly, which is just the end point, so 2 pi over 3 plus 2/3, subtract out my beginning point, which is 2/3. Okay? And then look what happens here. Look what has occurred, okay? That 2/3 minus 2/3, okay, those cancel out. And what I'm left here with is that it's 2 pi over 3. And my period length now is 2 pi over 3. And that's just found by taking the end point, subtracting the beginning point. And that will always occur in these types of functions where you don't have pi. But the next question is then how am I going to figure out what the next points of the plot are going to be? Well, I just come up here and I talk about the interval. Well, a circle, the nice thing about it is we break our quadrant into 4 points, and that's the nice thing about the sine function, the cosine function, is that it goes in those interval steps each time, and they're the same exact distance. So all I have to do is sit here and divide this by 4. But now it's a fraction, so remember that if I want to figure out what the interval length is, okay, from one critical value to the next, so I always start off this idea of having my critical values. And the very first critical value that I have here is 2/3. To get to the next critical value, I just add in this 2 pi over 3, this 2 pi over 3, okay, divided by 4. Well, that's multiplied by 1/4, okay, and that's going to give me my interval step. So let me write that instead. So this interval step, let's start there. Well, 2/3 times 1/4, just doing some reduction here, the 2 and the 4 reduce, and there's a 2 there. Pi times 1 is pi. 2 times 3 is 6. So I'm pi over 6 each step away from the start, and then I can go all the way up to this value here. So let's talk about that now. So let me erase some of this work. Okay, so the interval step is pi over 6, and I'm going to now talk about these critical values. Okay, the critical values are all going to be what are the inputs that I'm going to plug in that allow me to utilize that pattern going up and down, because that's really the hard part, is determining what the inputs are. Not so much the outputs, because you just follow that pattern. So I start at 2/3. That's my very first one. My next critical value is just pi over 6 away. Well, 2/3 plus pi over 6. I don't know. Well, this is nice because it's just 2/3 plus pi over 6. To get to the next one, we'll add pi over 6 to this. Well, 2/3 plus, well, pi over 6 plus pi over 6 is 2 pi over 6. Well, that just reduces to pi over 3. And notice how I'm just leaving it in this form, okay? To go to the next one, well, now I've got 2/3, okay, plus another pi over 6. Well, this was 2 of them. Well, now I add another pi over 6, which makes 3 pi over 6, which makes pi over 2. And to get to my last one, here's the nicest thing about it, is that I add another pi over 6 to this, which this was 3, so add 4 pi over 6, you get 4 pi over 6, which 4 over 6 reduces to this 2/3 pi. So now I have this 2/3 plus 2 pi over 3, and lo and behold, what you have here is that this should match, okay? And now that those match, I'm good to go. On a graph, to be honest with you, I'm not going to label these ones. I'm going to know that I'm going to use them. I'm going to label the beginning point and the end point, and I'll show you what I mean by that, to leave this in exact form, just in case your professor wants it to be exact. So, back to this idea of vertical and amplitude. Okay, I'm going to draw in my graph here. Remember, I start with the vertical shift to talk about the axis of picking up and moving at something. So I'm going to go down 1, so -1. So I draw in my new dash here. Okay. The next thing that I'm going to do here is my amplitude. Let's utilize that. Well, my highest point is going to go up 2 from here, so 0, then to 1. Goes down -2. Well, it goes down another 1 to -3. This is 1, this is -3. There's my amplitude points. That'll be started. My starting point is 2/3. Remember, 2/3 is a number, but that's what I'm going to use. So the important thing here is I'm going to label this as 1. Okay, I'm going to have this graph labeled as being 2, and then that's my 3. Okay. So, this value here, 2/3. We'll break that into 2/3. There's my 2/3. There it is. Okay, and I'm going to draw that down on here. I'm going to use these to help me along the way. The next thing I need to know is where's the endpoint approximately? And approximately the endpoint is that now I'm going to stick this into a calculator very quickly. So what I'm going to get here is, turning it on very quickly, I'm going to do 2. All right, 2 divided by 3, hit enter. I get 0.666666 repeating. And I'm just going to add to that this idea of 2 pi divided by 3, hit enter. And I get approximately this idea that this here is approximately 2.76. And the only reason I'm using that is so I know this endpoint here. So I'm going to say that, okay, that's 2/3, that's 0.66666, 2.666. So I'm going to put my value right here. And the next thing I do from here is I just look at this and I do the best I can to eyeball breaking it into 4 equal parts. So there's that, here's this, and there's that. Okay, so essentially what I've done is broken it into 4 parts. I've got my starting point, which is 2/3. I'm going to label this as being 2/3. And I'm going to label my end point now as being 2/3 plus 2 pi over 3. And I'm going to leave these critical values labeled so that they know that each one of these critical values, had I wanted to find it rounding, would be just by calculating this value. Okay? And then after this, all I do is I utilize my function. So the starting point at sine is 0. Okay? So I just put it on this new axis, and I say to myself that, okay, if I plug 2/3 into here, it would give me 0. So that's where the sine of function would be 0. At subtract 1, and then that's the coordinate I'm at. So 2/3 -1 is the coordinate that I'm now at. Okay, so then I utilize it. So I go to my next critical value. Because it's positive, I go to the maximum. So here, drawing it in, go to the maximum. Next critical value is at a 0. I'm zeroing value into the function is what I mean by that. The next value, I go down to -3 utilizing amplitude. And then my last value come up here back to the 0. And then I just simply draw it in. And there's my sine curve drawn in. Remember in the video prior to this I rounded. So if you want to see the rounding way of it, this is the exact method. The exact method can get a little bit more confusing when I start talking about how do I get this pi over 6. Well, the interval was formed by that. Remember that this, literally I just left it in the form of the exact because I didn't want to round it this time. At the end, I did use rounding right here, okay, to talk about where's my ending point going to be. So I plugged into the calculator. I rounded as best as I could on the graph because I'm drawing it by hand. And I plugged that value in, and that was it. Simply broke this into 4 equal steps. So I broke it in half, and I broke each one of those into half. And then I plotted my points using that pattern of sine. So I hope that helps with this when you don't have pi in here. And again, without pi in here, it does make it harder. But just remember to go back to that 0 to 2 pi. You still have to use it. There's nothing way you can avoid it. So I hope that helps.